Hello, everyone. Welcome to today's webinar. Happy Tuesday. We are going to get started with NewTechWood today. We have Stephen here, and he will be discussing uniting sustainability and aesthetics, wood plastic composite cladding for Rainscreen Assemblies, decks, and railings. Before we get started today, I want to let you know a few things about the presentation. First one, it is AIA approved, so I will be dropping in a form that you can fill out in the chat in case you didn't already submit your number, so you can make sure you get credit for today's presentation. Second thing, we will be conducting a poll about halfway to 3/4 of the way throughout the presentation. This is a really great way to connect with Stephen and anyone at NewTechWood later for samples, project-specific support, or anything else you might need. And the last thing, Stephen, if you wouldn't mind stopping sharing your screen so I can show all of you guys how to get connected with NewTechWood later. So if you go onto Acelab's website here, you can simply start typing in NewTechWood, clicking on manufacturers, and they have a really great brand page here with a little bit more of a description about NewTechWood, the best person to contact, as well as some really great product information here. We're simply able to click on that product, find out more details here below, and add it into any project-specific firm library, project-specific schedules or firm library schedules. Last thing I'll show you before we get into the presentation is another great way to connect with NewTechWood. I'll drop this link in the chat as well, but you can request things like lunch and learns, virtual presentations, or AIA credits for NewTechWood, along with many of our other manufacturers as well. So watch out for a few links in the chat, and I think whenever you're ready, Stephen, we can get going with the presentation.
Absolutely. All right, let me get that going back. All right, should be all set here.
Yep.
All right, everybody. So again, thank you so much for the introduction. My name is Stephen Saxxe. I am a sales account manager. I handle the Western US for NewTechWood, and I'm going to be going over the AIA-approved presentation for uniting sustainability, aesthetics, wood plastic composites, cladding for Rainscreen Assemblies, decks, and railings. That is the last time I will say that whole big mouthful, but there is a lot of information I'm going to be going over during this. I'll have some Q&A at the end if you have any follow-up questions from the presentation, and afterwards if you have any new tech. But as I get into the presentation itself, first thing to cover is going to be, so again, like as mentioned, this is an AIA accredited course, and if you didn't already get your AIA number, I think the links for all that information should be showing up in the chat here in a minute. It's a 0.1 CEU value course, and it meets all of the requirements required for the crediting. So the purpose and learning objectives here, so you're going to hear me say the word wood plastic composite, or WPC, a lot during this presentation. So that's the first thing I'm going to establish, is WPC equals a wood plastic composite. So wood plastic composites have been around in the US for a couple decades now. We've been through a couple stages of what the first generation of wood plastic composites were to what the current generation of wood plastic composites are. And I'm going to be walking through that first generation all the way up to the current generation, and through the factory process, green beds, some of the products that are up WPCs. So as we dive in a bit more, the contents of this are going to be, first off, what is a WPC? So what is a wood plastic composite? What are WPC rainscreen and claddings, other exterior applications, and then a general summary. So WPCs at a base level are made of two things: wood fibers and recycled high density polyethylene. That's your two basic things that make up the core of any WPC is recycled plastics and recycled wood fibers. 90s, roughly, when they became a large item in the United States, North America. And then the current generation of WPCs usually see four-capped siding to those WPCs that creates a polyramic shield. So it's usually capped in polymer, whereas the original generation of WPCs was just that composite core, and that came with a lot of first generation issues that we'll get into. But the current generation features that polymer shield so that it stands up to weather, sun, water, scuffs, just all of the elements that you're worried about for an exterior product. WPCs get used in a lot of different products. Some of the main ones that you may have seen in your markets are going to be decking, deck tiles, and siding. Decking and siding being the two largest categories of what WPCs get used for. So first off, getting into the manufacturing process. So there's a two-step process, compounding and forming, that is used to make the vast majority of WPCs in the market. So you mix your wood fiber, wood flour, and your thermoplastics. So just different manufacturers have different mix quantities, higher levels of plastic, higher levels of recycled wood fibers, different ratios that they use to make theirs and to achieve a different level of consistency and or sustainability. But bulk of what is done is mostly a interaction between the hydrophilic wood and the hydrophobic plastics. So one resisting water, one absorbing water, and then a coupling agent, and that is what allows them to have such a dimensional stability that is greater than just a solid wood. And then the second step is going to be your forming. Couple different forming methods: extrusion, injection, and molds. Most use extrusion. That is still the most common method for producing WPCs, but there are different types of extruders: single screw, double screw, final form shapes, and then the others with injection and molds that are used to make a variety of WPCs that you're going to see in the market. Now, the new generation, like I mentioned, of WPCs are fully capped. So what does that cap? That cap is usually made from a polymer. Again, different companies are going to use different polymers and different chemical combinations to make their outer coated polymer at different thickness levels, but it's going to create a co-extruded cap so that you have a high temperature mold, but it's not an adhesive. It is usually annealed or some other heat temperature that is used to make that composite fit with that polymer and then bonded to it so that it keeps the air inside during the winter and then the cool air inside in the summer. So it accomplishes both to allow it to be a all-weather product and survive longer in multiple climates. And then you have the composite core that we went over that makes up that inner part, which is the majority of the material. One of the big reasons a lot of people move to WPCs instead of just the durability and sustainability is the green benefits. You know, it's one of the great things about WPCs. Most WPCs in the market are produced using 95% or higher amounts of recycled materials. So again, with the waste wood, whether it's furniture cutoff shavings, sawdust, there's a variety of different things that get used as those wood fibers. And then for the recyclables, you have anything from plastic milk jugs, bottles, other products that end up in the landfill that get taken from recycling plants and sent to WPC manufacturers in order to produce what is now referred to as the current generation of WPCs. This helps reduce carbon footprint and helps take up a space in the market that natural wood products are having a growing demand for, but you have a wide variety of a consumer base that wants that look of natural wood without having to have the sustainability that they have to do to take care of it over a long period of time of having to go out and stain it, clean it, remove molding pieces. And then, of course, WPCs are 100% recyclable without having to worry about toxic chemicals or finishes when you are cutting the product. So there are a couple of green benefits that are also available for credits depending on the areas and the requirements of your building codes. So I'll go over those really quick. You can have 1 to 2 points in heat island reduction, a point in building product disclosure optimization for environmental product declarations, 1 to 2 points in sourcing of raw materials, depending on the manufacturer. It will depend on how much of the product that they can say is completely from recycled materials, which follows this little code over here, this formula on pre-consumer recycled materials versus total recycled content. And also material ingredients going into, again, building product disclosure and optimization to get 1 to 2 points in green LED benefits. Now, talking about cost and maintenance when it comes to WPCs versus other products. So wood is an expensive, ongoing, costly maintenance. You know, like I mentioned earlier, you have to stain it. You have to go out and make sure that pieces aren't molding. You have to account for the elements overtaking it. Every couple years, you're having to repaint wood products. So when you want the look of real wood without the maintenance, that's where WPC siding and decking is a more affordable alternative. Now, WPC is roughly half the price of natural wood at the end of the playing field because you don't have to paint it, you don't have to stain it or refinish it. It is traditionally a higher upfront cost. So you will see a higher cost at the beginning of buying a WPC material as opposed to natural wood. But that roughly half price margin is taking into account the lifespan of your average wood deck or wood siding compared to your average WPC that you encounter in the market and the overall maintenance cost that comes into both. Now, WPCs are proven to have a higher level of durability and longevity for use in the market. You have higher stability, higher wind applications, better fade resistance, stain resistance, mold resistance, and fire resistance, along with pesticide resistance. You're not having to worry about termites, carpenter ants, carpenter bees, any of those burrowing wood insects that are the bane of regular wood products or other wood-based products. The staining is something that you don't have to worry about as much with the fade resistance. Most manufacturers of WPCs are offering anywhere from a 25 to a 50-year warranty on their products, depending on what level of WPC and polymer they're using. But it's just an advantage that you have over wood-based products. Speaking of those warranties, like I said, most WPCs are backed by long-term residential commercial warranties. For most WPC manufacturers, you're looking at on siding and decking somewhere around a 25-year on residential projects and a 10-year limited warranty on commercial projects. Every WPC manufacturer has a different specification on what they will and will not cover in their warranties. So for any of that information on a specific manufacturer, please reference their guides on their warranties. For deck tiles, you're usually seeing somewhere around a 10 on residential, 5 on commercial limited warranties. But in general, WPCs last longer, require less maintenance, and put recycled materials to good use, creating a natural wood look without all the extra work. Now, getting into the Rainscreen part of a WPC system. So first off, what is a Rainscreen? So in this course, we talk about the 4 Ds of exterior wall design, followed by review of rain screens. So going over moisture management and rain penetration. So the largest source of the problem of just moisture issues with exterior buildings is rain. And a true rain screen system is something that just really helps solve that issue. So first of all, what are those 4 Ds? Deflection, drainage, drying, and durability. That is what goes into making a rain screen system, keeping the precipitation off, draining away water, drying, they'll allow it to evaporate, and durability, just selecting materials so they can withstand periodic moisture without deterioration. Let me see. I got a quick. What important WPC and how does it inspect? Yes, so I am about to get into that. I see that you got a question about rain screen cladding. So this is the section I'm actually about to cover and get into that. So excellent question. All right. So, oh gosh, yeah. Okay, so rain screen. So first of all, a rain screen is an exterior cladding infrastructure that stands away from the wall. So different manufacturers have different specs for this. For most, you're looking about a 1/4 inch gap from whatever the exterior wall is between, or the existing exterior wall, before having the siding added. So the importance of a WPC in this application is that for most of them, because of the polymer, they are resistant to all of those things I covered earlier, like mold, mildew, any of the things that you traditionally have to worry about putting some sort of a water-based sealant on woods or just having pressure-treated wood. Almost all of your current generation of WPCs do not have any issues with rain or water because they are completely capped in polymer. So there's nowhere for water to penetrate and get into the composite. But what makes a full rain screen is a combination of that WPC, tongue and groove systems. So as you can see on this diagram here, you see that there's a tongue and a groove that each piece of the siding is fitting into. And then an airflow with a standoff gap between the exterior siding and the wall behind it, whether that's a wood-based wall going on straight onto Tyvek, going on to a masonry such as stucco or just brick. The material behind it for most manufacturers doesn't matter, because if it's a true rain screen system, the tongue and groove plus the clip system plus the gap created by it is what allows that entire system to go together. So, and yeah, it helps reduce the amount of water that is going to be in primary contact with the building. So this helps to meet the National Green Building Standard, also currently meets international building codes that were updated as of 2018. Most manufacturers get these updated as they come updated from IBC or National Green Building Standards. But I just touched on a little bit of this, but what makes up the total components of a rain screen system? So it's the outer cladding, which is your WPC, your air gap, your WRB, and your flashing. So your flashing being either existing trims from a manufacturer that are going to cover, say, like these window and door areas that you see, or these top portions that go over. Where is this? Yes, this is what I was looking for. Yeah, so your windows and doors, your portions that go over your trims, just that is what makes up your flashings. But lots of materials get used for the outer cladding, both hydrophobic and hydrophilic materials. Preferably the outer cladding material should be hydrophobic. So air gap, like I just explained, it's just that 1/4 inch or greater gap that's set between the material and your siding. So your drainage plane is your WRB, so it's your water repelling material. So that's your house wrap sheeting, paper, any of those installed on the backside. Most WPC materials allow this to just be like your standard Tyvek. Doesn't have to be a specific weather barrier system. It can just be the existing house wrap for most WPCs. And then flashings, so just the pieces of impervious material that are there to prevent the passage of moisture in joints. So then WPC for wall systems. So this is something that just helps create durable, lasting material for a rain screen system. So it has the longevity and the toughness of capped wood plastic composite that allows air to circulate, but not the drawbacks that come with having to do this with a wood-based system. So these traditionally meet all of the exterior building codes and usually exceed existing building codes and testing requirements for existing walls just because they're more durable and yes, Mark, yeah, it allows air to circulate. So whether you're doing a horizontal or a vertical installation for one of these products, you're going to have a air gap system that's behind it that allows the air to circulate so that in the case of any moisture that does get back there, or let's say the house is sweating from the Tyvek, like moisture is coming from the outside in, air circulates so that there's nothing that stays back there and keeps moisture trapped behind the siding. So yes, that's exactly correct. And then with WPCs, you have a great amount of design flexibility, broad ranges of textures and colors, subtle ones, super eye-catching ones. It's a great amount of flexibility you have with WPCs that you don't necessarily have when it comes to regular wood. And again, tongue and groove cladding is what makes it a true rain screen system because you have a clip system that most WPCs are sitting on that allow it to sit in between each board. So like if you spray it with a hose, you're not going to have water that's penetrating in between the boards. Cladding profiles are also becoming very popular in WPCs in a European style, where you have castellation flutes that are anywhere from a inch to half an inch in width. Usually they're somewhere around an inch thick with a hollow piece in the middle to complete the castellation, but still have that European look. So then board and batten cladding features classic vertical design with alternating wide narrow planks. Shadow line profiles have enhanced groove for better management. So you've got a wide variety of options when it comes to some of those products. So then the cladding clips that I just went over, the current generation, the new generation, I should say, of WPCs use aluminum cladding clips that keeps that 1/4 inch gap to create that airflow that we just went over using a 2 screw hole system. The top hole that you see on these clips is used to hold the material against the wall, whereas that second hole down in the middle is what's used to help control expansion and contraction. Because it is a composite material, it is going to expand and contract over time. It's going to get a little bit longer in the summer and a little bit shorter in the winter. So for most WPCs, you will use this second hole in the clip according to manufacturer's specifications in order to determine where you need to control expansion and contraction. Again, most manufacturers will have very explicit instructions in their installation guides on how you should go about installing these to control expansion and contraction correctly. But then again, I briefly touched on the trims, multi-accessory trims to help hide expansion and contraction so you don't see when there is slight differences in how one board expanded and how a different board did, just covering those joints to have a nice clean finish. It's a much more lightweight material than other alternatives, especially when it comes to the siding. You'll see some WPC manufacturers trying to use their decking as a siding application. Generally not recommended. Make sure to check with WPC manufacturers that you are using their siding material for siding, not their decking material, just because it's usually about half the weight for their siding material as opposed to their decking material, and is designed to be facilitated for these installations. Horizontal and vertical installations, there are differences across manufacturers on what they suggest for specifics on their horizontal versus vertical installations. For most manufacturers, the biggest difference, or the biggest consistency, I should say, is on horizontal installations. You'll be having your joists no more than every 16 inches on center. And for vertical installations, you'll be having them every 12 inches on center. That's for siding applications. When it comes to decking applications for WPCs, your joists should be every 16 inches for residential installations and 12 inches for commercial installations. So again, just example of a horizontal application. You've got the insulation back there. You have your breathable membrane and your WPC siding that's getting installed, in this case, over some furring strips. And again, like I mentioned, there will be expansion and contraction with WPCs. So it's very important to reference manufacturers' installation guides or installation videos on what they recommend on controlling that expansion and contraction. For most manufacturers, it's going to be something along the lines of, for every single board, let's assume you have like a 16-foot siding board, you're going to have one clip in the middle of that board that is going to have the locking clip that you see here with the locking screw in the picture on the right. And that's going to make the board expand and contract out to the sides. So again, reference your manufacturer's installation guides to make sure that you're doing this in the most, just the best application. For vertical installations, you're usually going to have your aluminum or wood furring strips or joists. To start, at the bottom, you're going to have some sort of a aluminum L bracket or a composite L bracket if your manufacturer offers it. To start off, having your joists put up, then doing your starting clips and starting your installations. Now, for maintenance on WPCs, even though it's going to be durable and it's going to last twice as long if you take care of it. So keeping it clean is very simple. You don't have all of the large amount of maintenance that usually comes with other forms of siding. Like, you don't have to get out a pressure washer and clean mold and mildew off. You don't have to sit there and restain it. For most WPC siding, once to twice a year, using like a soft cloth and a regular speed garden hose, so not a pressure washer. It's actually very recommended to not use a pressure washer on WPCs because you risk just tearing off bits of the polymer and exposing the composite core. So in most cases, soft brush, like a mildew cleaner and or just Dawn dish soap or something like that, like a degreasing cleaner. And that's it. WPCs with their polymer are very easy to take care of. Yeah, just not using pressure washers or very abrasive sponges, just gentle wash stream and a soft cloth, and you are good to go on what you need to do for cleaning WPCs. And you only have to do that like once a year, if that. So other exterior applications for WPCs. Lots of other exterior applications are used for WPCs, whether it's decking, some interior applications, or like semi-interior, exterior, outdoor kitchens. window and door trims, lots of different things that WPCs usually have. And again, the upfront production cost of WPCs for a deck or other projects is usually going to be somewhere around 15% higher upfront, but it's the less maintenance and life cycle cost that brings that total cost down over time. So WPC siding versus decking. Very similar, but there's a couple things that are pretty different. So WPC siding uses interlocking planks. That's that tongue and groove system that we just talked about, where decking is not tongue and groove. It's used either using common deck screws or hidden fasteners, but there will always be a gap, excuse me, in between every single board. So you're going to have gaps in between your horizontal boards and between your vertical boards. You're going to have gaps, and that is an important factor of WPCs. So remember, with the WPCU siding system, the rain screen has a gap between the wall and the siding so that air can flow. Decks don't have the same full protection against the elements. So for a deck to last longer, you need the water to be able to pass through those cracks down past your joists and then just go back into the water so that it can run off. And when you have a contractor installing a deck, most decking installations, you're going to have them installed on a very, very slight pitch, somewhere around like a 16th or an 1/8 of an inch, so much like that it's not noticeable when you're traditionally walking on it, but it allows water to run off and also, or just fall in between the cracks of the deck. So when I was talking about the old generation versus the current generation of WPCs, decking is where we saw this the most because WPCC siding, I keep saying WPCC, WPC siding is what we kind of came out and saw within the market once the current generation of WPC decking came to where it's at. When we got to this full cap 360 degrees of cap in the WPC market is where you started seeing a lot of manufacturers come out with siding instead of just decking that was used as siding. So that's where we got to this. The first generation uncapped, it was just pure core. Second generation had like a wood powder over it capped. Second generation was just capped on the top. Third generation. Fourth generation was capped everywhere except for the grooves of the hidden fastener decking. You will still see some of that in the market. And the only reason that a manufacturer will not cap in that groove is because they capped an entire solid board and then just cut out their grooves and they didn't go back to recap it. It's just a cost saving measure. So it doesn't deteriorate immediately the quality of the decking, but there is a higher chance of water penetration when you have that uncapped groove. And then finally, you have the capped 360 generation of composite decking. Most manufacturers have moved to this for both their ungrooved and grooved decking so that you have the best way to fully protect a deck. The first generation of non-capped saw a lot of issues with crumbling the upper cap. Second generation, you saw like radiation moistures, lots of issues when there was uncapped composite. So that first generation, the uncapped powder wood had massive scratching issues. You see it was obvious, and you over well. So if it was a consistent fading across all of the boards, you could at least have one color the entire time, but it was inconsistent on how it faded. You had fungus, mold, and mildew issues with uncapped composites that you just had customers that were obviously very unhappy with what they were getting, and cracking boards, and of course staining of materials, whether it was spilling drinks, wine, different things onto those uncapped materials. So the first generation of WPCs had a lot of problems that a couple decades of science have helped remedy. So that first layer, so that second generation, that second, third generation, when they started with the capped halfway, their problem that they saw a lot of was cupping. So they would start folding up. It looked almost like a teacup just starting to fold up. And that was because it wasn't capped on the bottom or in the grooves. So you started seeing cracking because it got into those grooves and then caused the capped portion to balloon and cup. So that was the big issue with the capped and capped halfway generation of composites. So completely capped with rooted grooves. This is that pseudo current generation where they'll take it, cap the whole board, and then cut their grooves out. You still see some of that. A board with uncapped still allows some moisture to be absorbed throughout the entire length of the board. So the potential for swelling, cupping, and cracking is lower than the half cap, but it is still much higher than a completely capped 360-degree board that you see now. So a conventional WPC on the left and a fully capped WPC on the right, you have higher stain resistance, less issues with the material itself. There's just a lot of better things that you get from fully capped WPC, less issues, longer lasting material. Yeah, again, against color fading, mold, mildew, all of the things that it's better at. But one of the more aesthetically pleasing parts of a 360 capped aesthetic or a 360 capped WPC is that you have a lot of colors available in WPCs. Now, you'll see most WPC manufacturers name their colors after existing types of wood because people in the market are looking for, they want something that is Brazilian Ipe wood. They were going to go to a lumberyard and get Brazilian Ipe wood planks to do their deck or to do their siding. So they want that color profile, but they want that color profile without the issues that come with it. Now, the thing that you can do with WPCs that you can't do with real wood without, staining, obviously, is you can get into wacky colors. You can have blue, green, red, different fun colors of decking and siding. That is a benefit of a fully capped composite because you just have the polymer that is that color, and your composite core is still your recycled plastics and wood fibers. And 360 cap profiles come in a variety of different materials and profiles, not materials, but different profiles, I should say. So you have your solid boards, that's for your decks or stairs. So the solid board will be used as your stair pieces or as a picture framing so that you see less screws, less deck screws into the deck itself. Then you have your hidden fastener or screw boards that just has that hollowed out edge so that it is still fully capped, as you can see from the imaging, but it still lets you do a hidden fastener installation system so that your deck doesn't have that appearance of deck screws throughout the whole thing. And then you have the current generation that takes some pieces out of the bottom. Again, still fully caps the bottom of it, but it's a little bit less of an integrity board that helps meet a price cost without having to sacrifice for the quality of a WPC. And with 360 capped boards, you can get different grains. You can have a more rustic grain. You can have more of a cathedral grain. Just different options that come with getting a deck board from a manufacturer of WPCs, because they can choose what grain pattern is going to go on that board. And again, with colors for 360 capped, you have, your teaks, your light grays, your walnuts, just all of the different options. You can get your ipe woods, your charcoals, your oaks, even getting into some custom colors, getting those greens and those reds like I discussed earlier. Maintenance for WPCs, again, unlike other decking options, they don't rot or fade over time. They perform well, and when it comes to anything that you might need to clean off of them traditionally, a normal garden hose and maybe some like Dawn dish soap if you happen to get something on there that's not wanting to come off. Yeah. Now, if you use a pressure washer, it needs to be with a fan tip at the lowest setting that your pressure washer can read to. Most WPC manufacturers still recommend just not using a pressure washer so that you do not potentially turn it on too high and run it. But in the case of needing to do it, just under 1500 psi, stay at least a foot away from, above or away from the product. And then there's a couple solutions on this chart over here for the right, for cleaning up different materials such as ice and snow, greasy food, mold and mildew, so on and so forth. Again, couple installation examples to just touch on where you've got, your teak and walnut, ipe, ebony, such as using them for around a pool, for commercial applications like at a Starbucks. And then a couple last things. So WPCs also traditionally get used in some railing applications and other products that you get to see. With WPC railings, you will see aluminum balusters usually used. So the balusters on most WPC railings are aluminum, not composite material, but 100% recyclable, no harmful chemicals, meets international resident codes in the IRC. And a quick note when it comes to railings, codes for local state or just local counties and state level vary greatly. So generally the IRC requires, a deck or balcony to have structural railing to pass as a home. So you have a great application that you can offer to some of your clients. And then deck tile WPCs, what this usually looks like is a WPC material on top of a plastic grid. Super DIY product that you'll see in the market. Zero construction required. You just snap them together. It is an excellent product to offer for rental homes. Rooftop decks is another one that a lot of manufacturers are seeing in the market get put on. So DIYs to veteran builders, these are an excellent little addition. Again, they just get slapped together. There's nothing fancy. But yeah, design flexibility with those, lots of different colors, 1 to 3 foot sections, accompanying trims, whether it's a total straight edge trim piece or you do a fascia trim piece for a ramp function. Lots of design flexibility, whether you make it look more like you have an actual wood deck out there covering a concrete slab to make it colorful, lots of options. So in summary of the presentation, fully capped WPCs have a composite core co-extruded cap and are capped on all 4 sides, with a polyramic shield. They have much higher durability and longevity than, say, your traditional wood products, and it's utilized for a lot of applications. Most WPCs are at least 95 recyclable materials. A lot are over 100%, or not over, but just are 100% recyclable, and use waste wood, recycled post-consumer plastics. WPCC siding is tough, has longevity, with an engineered wood design to have a true rain screen assembly. Decking, popular choice. Not all WPC deckings are created equally. Check with different manufacturers. And then 360-degree provides, UV protection, mold and mildew, all of the different things that you usually suffer for with wood-based products. Similar to other cap WPCs, railings are made from WPCs, don't rot, warp, twist, crack. Doesn't need to be stained, repainted, any of those things. And then your deck tiles made from natural wood grains are on an interlocking plastic base, ideal for roof decks or patios. So when you're gone, you want that real wood look. Cap WPCC products are the beauty of wood without the maintenance. And then here's just a couple of resources available to y'all as well. So in conclusion, I know Alyssa went over how to find information on WPCs and reach out to NewTechWood for WPCC questions, but either all, thank you guys so much for listening to my presentation today. If you have any additional questions about the presentation, I can field those now. And then if there's any NewTechWood questions, I can answer that after any questions about the presentation.
I think you answered pretty much all the questions live, which was great. If anyone does have any final thoughts, feel free to drop them in the chat now. But I know a lot of people requested to connect after today's meeting, so you might be able to answer some questions there as well, if that works.
Yes, absolutely. Yeah. So if y'all have any questions that are specific to WPCs, not just NewTechWood questions, happy to help with those as well. But that is I don't see any questions popping up. So that's going to be like the formal conclusion to the AIA presentation. If anybody has any NewTechWood specific questions, I can answer those now. But I know Alyssa gave you guys the form to reach out for information about samples, getting NewTechWood specific product knowledge sessions set up. So I can help with anything right now, but if you've got more than just a single question, yeah, please fill out the form that she linked you to.
Perfect. I think we can end early, Stephen, unless you have any other final thoughts too.
I do not. That is the entire presentation. I do usually try to keep it to 45 in case anybody does have some extra questions that they want to stick around for.
Yeah, no, that's great. Okay, well, we'll look out for messages in the chat after, and I hope everyone has a great Tuesday. Thank you so much for the presentation, Stephen. It was super informative. And anyone will have an option to get this recorded. Look on Acelab webinars in case you want to forward this to any other office members or stuff like that. Okay, thank you so much. Have a good day, everyone.
All right, thank y'all.